Let's use reduced row echelon form to solve the system here. So our first step, we want to write this in an augmented matrix. So we're just going to take all the coefficients on all of the variables, and we're going to just have those. So, and we're going to put the constants in there as well. So the first thing we can probably notice is that there's no x term. So just maybe to help us out, we can put a 0 there. That's fine. So we want to just take all of our coefficients and put those in a matrix. So we got 2, right? We got 2, -1, 1, and then a -1. All of these coefficients here, we got 4, 3, 5, 1, 4, 3, 5, 1, and then 0, 5, 3, 4. 0, 5, 4. Okay, so then we put our square brackets on there. We got our line separating the constants. So let's just kind of remind ourselves of what we're doing when we're doing this, right? We're just putting all of the x coefficients in this column, all the y coefficients in this column. Here's all of our z coefficients. And then these are all constant. So our goal here is to write this first in reduced row echelon form. So what that means is I want to have 1s in these positions, and I want to have 0s everywhere else. The constants are going to kind of change around, but our end goal is to get 1s in these positions and then 0s everywhere else, if we can do that. So let's get going. This is nice. We've already got a 0 in that position, so that'll probably end up helping us out here in the long run. But we'll see. First thing I can see here that we might want to do is we can get a 1 in this position by just dividing everything by 2. So if I take, I want to replace row 1 with 1/2 of row 1. So I'm going to just replace a row with a constant multiple of itself. I'm not going to change these rows around either. I'm just going to, that's all we're going to do here. So I got a 1, and then I've got a -1/2, 1/2, -1/2. Just divided everything by 2. And then this other stuff stayed the same. So I got 4, I've got 3, I've got 5, I've got 1. And then this one doesn't change. I've got 0, 5, 3, 4. All right, next step. We want to get rid of this 4. So I can take a multiple of row 1 and add it to row 2. So I want to replace row 2. I want to replace that with -4 times row 1 plus row 2. So I'm going to take -4 times row 1, all those positions, and I'm going to add it to row 2, and I'm going to replace row 2 with that. I'm not going to do anything with this one because I already have that how I want it, and there's a 0 there, so we're good. All right, so I'm not changing row 1. We are changing row 2, though. We're taking 4 times row 1, -4 times row 1. So -4 plus 4, that'd be 0. -4 times this guy would be a +2. Plus 3 would be 5. Okay, 1/2. So -4 times 1/2 would be -2. Plus 5 would be 3. And then we've got what? -4 times this one would be +2, plus 1 would be a 3. Okay, so there's my row 2. And then I've got row 3. We didn't change it. And we kind of should have maybe some bells and whistles going off here because we've got 2 equations here that look to be the same here. Well, not quite the same. But we want to keep going, and we want to put this into row echelon form, don't we? So let's continue on here. So we want to make this be a 1, right? So we want to make that be a 1. So I can just take 1/5 of row 2 and replace row 2 with that. We can do that. So I got 1, -1/2. 1/2, -1/2. Man, this is going to get kind of ugly. So row 2 here. So I'm dividing everything by 5. I got 0, 1, 3/5, 3/5, And then this one doesn't change. I got 0, 5, 3, 4. Okay. Oops. So right, this was the only one that changed. I think I was off the page for just a moment there. Sorry about that. Okay, so next, what do we want to do next? We want to make it so there's a 0 here and there's a 0 here. This one's going to be easier, but we're still going to be able to do this, right? So we want to take what? I'm going to replace row 1 with negative 1/2, or excuse me, positive 1/2 row 2 plus row 1. So I'm going to take 1/2 times row 2, I'm going to add it to row 1, and this is going to eliminate that term right there. This is going to kind of be a mess for us, but I think we're going to be okay. And we also wanted to get rid of this 5 here, didn't we? So let's take and we'll replace row 3 with negative 5 times row 2 plus row 3. Okay, so row 1 is changing. We're taking 1/2 times row 2, adding it to row 1. So 1/2 row 2 is 0, plus row 1, that's a 1. 1/2 times this plus this would be 0. 1/2 of this, okay, so 1/2 of this is 3/10. 3/10 plus 1/2 is 3/10 plus 5/10, so that's 8/10, which is 4/5. Okay, and then we can do the same thing here. We've got 1/2 of this one is 3/10 plus 1/2 would be negative 2/10, so that's negative 1/5. Okay, we can do fractions. And then row 2 isn't changing. We've got 0, 1, 3/5, 3/5. Okay, and then our third row, we're going to have negative 5 times row 2 plus row 3. All right, so negative 5 times row 2, that's 0, plus row 3, that's 0, so we got 0. Negative 5 times row 2 is negative 5, plus this one would be 0. Okay, good. Negative 5 times row 2 would be negative 3, plus 3 would be 0, okay. Negative 5 times this one would be negative 3, plus this one would be a 1. Okay. All right, so this is now in reduced row echelon form. If we go back and take a look at what it means to be in row echelon form, it was mostly about these leading ones and the zeros, the remaining digits in the columns containing a leading 1. So these are the only 2 leading ones. We're not able to get a leading 1 over here because anytime we would want to make one of these be a 1, then we're going to be changing either this or this, and then that's going to kind of be undoing what we did. So this is reduced row echelon form. And further, we can see that we have a contradiction right here, right? So if I just looked at this specific row right here, what this is saying in the form of the, or excuse me, not an x, it's a 0. So what that is saying in the context of the original problem, we got 0 equals 1. This is never true, right? That's a contradiction. So that means that there's no solution to this system, and we call it inconsistent. So it's different when if we were to end up with something like 1 equal 1, or excuse me, 0 equals 0 would be what we would end up with here. That's different. That would mean that we would have infinitely many solutions because it's a dependent system. And we would express our solution for that in a different way. But for this one, we just say it's inconsistent.